Dart School presents number patterns. A set of numbers is referred to as a sequence. In a single sequence, when each number is related to the previous one by a fixed rule, they follow a specific pattern. Let's say we have a set of numbers 1, 5, 9, 13, 17 and so on. Now if you look at any number on the set, for example, let's start with 5, it's exactly 4 more than the previous number. So if you add 4 to the previous number, you get 5. In the same way, if you add 4 to 5, you get the next number, which is 9, and this pattern, this specific pattern continues. 13 plus 4 is 17 and so on. So the next number on the sequence, even though I have not written it down, you know it's going to be 21. Let's look at another sequence. Let's say we have the first number is 2, then 4, then 8, 16, 32, 64 and so on. Can you recognize the specific pattern on the sequence of numbers? It's multiplication by 2. You multiply one number with 2, you double each number to get the next number. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16 and so on. So you know the next number after 64 is going to be 64 times 2, which is 128. The numbers on a sequence are referred to as the terms. So these are all the terms in that sequence, and these are the terms in the second sequence. So we have this as the first term, often referred to as T1. This is 4 is the second term in this sequence, referred to as T2. 8 is the third term, T3 and so on. And once we recognize the rule that the sequence follows, for example, a plus 4 on the first one, a times 2 on the second one, you can pretty much find any term on that sequence. Let's say Tn, where n can be any number. We have T1, we have T2, T3, T4 and so on. You could find, let's say, T50, T100. When the difference between the consecutive terms in a sequence is fixed, we call it a linear sequence, also called an arithmetic sequence. In an arithmetic sequence, the numbers can also decrease. So you can have a sequence as 20 and then let's say 17, 14, 11 and so on. If you look at 20 and 17, the difference is -3. If you look at 17 and 14, it's a -3 and a -3 between 14 and 11 as well. So the difference between the first term and the second term is equal to the difference between the second and the third term, which is equal to the difference between the third and the fourth term and so on. Now the difference can either be positive or negative, doesn't matter, as long as it is fixed. -3 in this case, +4 in this case. It still qualifies, they both qualify as arithmetic sequences. That difference out here is called the common difference of the sequence, of the arithmetic sequence. Only an arithmetic sequence can have a common difference. For example, if you look at this sequence of numbers where each number is multiplied with 2 to get the next one, the difference between the numbers is not fixed. There's no common difference. So for this arithmetic or the linear sequence, we would say the first term is 20. It's denoted with the letter T1. t with the subscript 1, and then the common difference, CD for common difference, is negative 3. Let's think about a linear sequence in which the first term is denoted by the letter A and the common difference is denoted by the letter D. So we have the first term as A, the second term is going to be A plus D. You add D to the first term. D can be positive or negative. If it's a negative number, that would mean the second term is less than the first term. So D includes its sign. The third term is going to be a plus D on this. Therefore, it's going to be A plus 2D. And the fourth term is going to be a plus D on this. And that's going to be A plus 3D. And so on. You have A plus 4D, A plus 5D. And this was the first, this was the second, this is the third, this is the fourth, this is the fifth, this is the sixth term on that linear sequence. Now if you look at these numbers, when this is 5, this is sixth term. When this is 4, this is the fifth term. When this is 3, this is the fourth term. That leads us to a general formula. We can say that the nth term denoted by Tn is equal to A plus n minus 1, 1 less than what n is. When n is 6, this is going to be 5. When n is 5, this is going to be 4. N minus 1 times D. Time for us to look at a couple of problems to solve. The first term in a linear sequence is 6. And the common difference is negative 5. Find the 12th term on the sequence. So it's given that is equal to 6 and the common difference is equal to negative 5, and we need to find the 12th term, which means T12 is what? Now if you look back at the formula, we have it there. Tn is equal to A plus n minus 1 times D. T12 is going to be equal to A plus n is 12, 12 minus 1 times D. Just plug in the values. A is 6, the first term, plus 12 minus 1 is 11 times the common difference is negative 5, which means the numbers on the sequence are decreasing, times negative 5. This is going to be 6 plus negative 55, which is equal to negative 49. So in that sequence, the first term is 6, and then you have certain other numbers, they keep decreasing. By the time you reach the 11th number on the sequence, there's a negative 49 out here. Let's take a look at another example. The fourth term on a linear sequence is 24 and the eighth term is 56. We need to find the first term. So let's think about this problem. We have a first term, comma, second, comma, third, comma, fourth. We have a 24 here, the fourth term. We need to find this one, the first term. Then we have the fifth, sixth, seventh, and the eighth term. And this is given to be a 56. Now, if you look at the fourth and the eighth term, you'll probably come to realize that the common difference has been added 4 times. So you do a plus D, fourth to fifth is a plus D, another plus D from 5th to 6th, another plus D, and another plus D from 7th to 8th. So therefore, from the 4th to the 8th term, the difference is actually 4D. And that 4D is equal to the difference between these two numbers, 56 minus 24, which is 32. To find D, you just divide both sides with 4. 32 divided with 4 is 8. We got the common difference. Now you want to go the other way this time. So this term is going to be 8 less than 24 because we are going the other way. D is positive 8. If you go the other way, you want to subtract, not add. So this is going to be 16. 24 minus 8 is 16. And then a minus 8 again. That makes it 8. And finally, a minus 8 takes you to 0. So the first term is 0, the second term is 8, 16, 24. You can pretty much find any term on the sequence, 32, 40, 48, 56, and so on. They happen to be the multiples of 8.